Assalamualaikum and hi, I'm Amirah Basir. I'm going to present my final project on studies of organic semiconductor-based UV light photodetector. My supervisor is Professor Dr. Khaulah Sulaiman. For decades of years, improvement in the parameters performance of the organic photodetector have been conducted. However, further studies still in progress to have a better performance in the sensing devices. Medicine is one of the most useful applications of the sensor devices. As we know, UV light is a harmful invisible radiation if we are excessively exposed to it. Thus, this project aims to design multi-layer photosensor specifically in the range of UV. Organic donor and acceptor materials are selected for the fabrication of organic photodetector, whereas in this project, the candidates are TPD and ALQ3. In the first part, I have prepared organic thin films of TPD, ALQ3 and their blend ratios. I deposited them on quartz substrate using spin coating process, which involves steps of applying solvent solution, rotating and drying. Later on, their thicknesses measurement was done. The optical and electrical properties were investigated to see the effect of mixing accepted ALQ3 into whole TPD donor. Analysis for optical properties was done on absorption and photoluminescence spectra. From absorption spectrum, estimated optical energy gap was obtained, while from the photoluminescence spectrum, the best photoluminescence quenching to be used as the active layer in the photodetector afterward was determined. The comparison between light absorption with emission of TPD film indicates that the emission occurs in the range of 400 to 500 nanometer is due to the reflection of absorption in the range of 300 to 400 nanometer. Overall, the organic blend of TPD ALQ3 has shown good light absorption and sensitive in UV wavelength. Thus, it is suitable to be used to produce UV sensor of organic semiconductor. The second part of the project is the fabrication of organic photodetector. The electrical behavior of photodetector was investigated from current versus voltage curves under two different wavelengths of UV light at 395 and 365 nanometer with comparison to dark. Two sensing parameters observed from the fabricated organic photodetector are ratios between the photocurrent to dark current at certain voltage and the switching time between the illuminated and dark states. There are increase in magnitude of photocurrent when put the photodetector under UV light compared to dark and when higher voltage is applied. The almost square light shape of response recovery plot shows that the photodetector has a good response to the UV light. In conclusion, the objective of this project to fabricate an organic UV sensor is obtained. For future study, it is worth to proceed in enhancing the performance of the sensor for the application in real market of organic photodetector. Furthermore, organic photodetector may be integrated with the Internet of Things for the real environmental monitoring. For example, utilization of a program in smartphone would allow a person to receive notification of danger UV ray levels. This will be a very interesting area to be explored in the future. What I've learned from this project is the importance of planning and scheduling. Since we take final year project while taking other subjects throughout the 2-semester period, it required us to carefully manage time for the project. Sometimes I might take extra time for the experimental part as it had to be finished on the same day to get a good result for further analysis. I am very grateful to be under my dedicated supervisor as I have learned a lot from her, especially in the skill of thesis writing. This skill is surely very useful to be used in the future as I intend to go further in the research area. I also met few experts while doing this project where I learned a lot from them. Thank you for watching.